So the panelists here are on a panel that is called the Path to IoT Security. And that path starts at the hardware, as we've heard the last few days. If you own the hardware, then you own the software. We've also heard that we need the tools to become available at scale to do the testing of the attack surfaces for it to improve. We've heard that you, present here, the people with the ability to reverse and debug and find the flaws in the hardware, are the ones with the knowledge to maybe bring about a change. But there's a whole world on top of a good initiative like hardwear.io, which gathers experts in this field and puts a focus on the importance of this. And on top of that is the whole policy layer. There's the blue team perspective of securing your enterprise. And the panel here today has someone from every spot in the ecosystem, more or less. Katie is involved with some of the Vasenar thing, which you probably know is not good for security research in the current version. Katie's trying to improve that. That's the legislative layer. Then we have someone on the panel producing devices. He's here. And we have someone purchasing and trying to secure the environments. And Jay is sitting right here. So it will be on the path to IoT security. The challenges are many, which we've heard over the last few days. And there are many things to discuss. So, where do you want to start? Katie?
So I think we had decided amongst ourselves amid the cocktails last night that we could have a great conversation that was only the three of us, but it wouldn't really include all of you. So we wanted to make sure that whatever discussion we had became more interactive with you. So especially those of you who have fallen asleep in the back, we do hope that you wake up in order to participate with us. But maybe it makes sense for us to kind of introduce ourselves in our focus areas. So and thank you for the overview of the direction of the panel. My name is Katie Masouras, and I am the founder of a company called Luta Security, which I started 6 months ago, where I help organizations and governments do vulnerability disclosure and potentially bug bounty programs. And you may remember me from such bug bounties as Microsoft's first ever bug bounty, and also in the United States, I created the US government's first bug bounty program called Hack the Pentagon, which was a successful pilot run earlier this summer. My perspective in all of this, having in a past life been a software penetration tester before, is that obviously we all knew that we relied upon the underlying architecture and security of the hardware, and that there were tons of security assumptions. And I think some of the talks that you saw yesterday, Joe Fitz gave a really great one that I was in the audience for, and he basically said, why do all of this, very complicated mitigation, bypass, exploitation, complexity stuff when you can literally flip a bit in the hardware and bypass authentication or own the device, et cetera. So I think as an ecosystem as a whole, from my perspective, I look at it like the elements that make a secure device, like any kind of IoT device. A mobile phone is a great example of an early, broadly adopted IoT device that's not necessarily part of critical infrastructure. Any of the security in the device, I believe someone else who was giving a keynote yesterday talked about all of the different players who contribute to the trust of the device, and it's not just the software makers on the relatively top layers, but it's all the way down the supply chain. And in the case of a mobile phone, you're dealing with chip manufacturers, OEM manufacturers of the devices themselves, operating system manufacturers, software developers, possibly end users installing and jailbreaking and all that stuff and changing, modifying the underlying control of the device. And then you also have mobile carriers, and all of them actually would have to work together in order to have a secure device. And it's the same, when it comes to a lot of IoT security.
Okay.
At that point, I'd like to turn it over to the man in the middle. Yeah, we put him in there. We
Complex
did that to
ecosystem,
him.
supply chain.
So hi, my name is Rob Brown. I'm from Trustonic, and I'm wondering what the hell am I doing here, because if you see my job title, it's marketing, IoT marketing director. And a whole bunch of you are hardware hackers. So I'm not a hardware hacker. I'll put my hand up and confess. But what I want to explain is how I got here. I started off on my security journey at Arm in 2005, where I marketed the smart card security course to a number of chip manufacturers who put these devices into things like bank cards and SIM cards. And on my first week at Arm, I sat next to somebody who's still there at Arm, who said, "Why on earth did you join Arm to sell smart card cores? Because we have this thing called Trust Zone, and that's going to kill smart cards." I thought, that's not a great thing to hear in your first week of employment. I went and found out about what Trust Zone technology is, because I thought, well, I need to know about this. And turns out it doesn't replace a smart card at all. It does a completely different thing and solves a completely different set of problems to do with securing apps processors versus microcontrollers and smart cards. So I ended up trying to push the Trust Zone technology to chip vendors and build up the demand for Trust Zone with a number of ecosystem players like payment companies, because here was a very useful technology that can protect things to do with payments like user authentication, transaction signing, that wasn't being really used in handsets back in 2005. So fast forward to where I am now at Trustonic. 4 years ago, we formed the company to build a software stack that runs inside the Trust Zone mode of an apps processor using the ARM Trust Zone. And to date, we've shipped 700 million trusted execution environments in Android handsets, and Samsung is the major shipper. And a lot of Samsung Galaxy devices today now use the trusted environment and Trust Zone to secure things like fingerprint matching and Samsung Knox enterprise security frameworks, and also things like Samsung Pay. But not only that, the trusted environment is open for third-party developers to add their applications into that trusted environment as well. So that was where I've got to with mobile, and that technology is coming to the Internet of Things. And what Samsung has done is created a module. This is an 8-core processor module designed to fit into any Internet thing. It's basically, here's a dual-core version as well. These are called Samsung Arctic, and they're basically the beating hearts of smartphones ripped out and ready to transplant into a number of devices, and Samsung's done this to accelerate Internet things time to market. Those things all have trusted environments in them as well. So in the Internet of Things world, things like biometrics, user authentication can be done in a secure space, just as it is on a mobile phone in the Internet of Things. So that's where we see some of the mobile technologies influencing Internet of Things. And I'll hand over to somebody who may buy this sort of technology in the future. Jaya.
One can only hope. So my name is Jaya Baloo. I'm the Chief Information Security Officer of KPN. And, we've all got I'm not going to introduce myself even further than that, but we've all got different parts of this puzzle to kind of fix. And that's the simple way to look at it. So I've got the network, you've got the device, and Katie's there to be badass and help us figure out what vulnerabilities there are and figure out how to close them as quickly as possible. So if we can take different parts of that puzzle, I think it really is a challenge. We all know what's broken, right? We've got a fundamentally fractured ecosystem. If you take a look at the multitude of protocols, the lack of standardization, the differences in implementation, that presents a challenge at the best of times. But we keep building new technologies with crappy, shitty, old vulnerabilities built in from the get-go. And then we're somehow magically with duct tape, although duct tape does do a lot of good things, supposed to, paste all these things together and somehow get it working. KPN introduced, and be really upfront about this, a LoRa network. Since we have people from all over, does anybody know that we introduced a LoRa network? Ah, okay. Well, you don't count because you work for KPN, but okay. So, but all right, that's good. The clue is that the CISO team, the security team, was really mean to operations when they tried to introduce LoRa, because you can imagine all these happy developers all ready to go. Look, we're going to be the first to have this cool IoT network. We'll beat all the Vodafones and everybody else. Although I'm just going to pick on Vodafone at the moment. We'll beat all those sucky operators. We'll be the more innovative one, and wouldn't it be awesome? And don't delay our timelines. Do we really have to get your security team and your red team to test this first? Really? And then when the red team comes out with the report of everything that we broke and they have to fix, do we really need to fix everything? Can't we just go live first and then fix it later as we go along? And you're the only security team that asks for this. All the other operators in the LoRa Alliance, they were allowed to go. It totally sounds like my 8-year-old, talking about the parties that he's not allowed to go to, that his friends are allowed to go to. This is the maturity level we've got when talking to operations people. This is the reason for the duct tape, if only to bind them in a corner of the room. So, not that I'm, suggesting that, but the point is that these are the challenges that we've got, and if you take a look at why we're such a pain in the ass, it's really because look at the actual implementations. We're talking about using this network for the electricity and lighting systems because LoRa is, by the way, long range. It's long range radio, and we're using it for street lighting, for industrial cooling, for smart waste, for Legionella detection, for street covers, sea pumps. Sea pumps are important in the Netherlands. But also like other cool stuff like luxury asset tracking and tracing and other kinds of tracking and tracing, smart office stuff. And, it's also gone into the more quirky of spaces with smart mouse traps. And only in the Netherlands do we have the connected cow. Imagine one of these badges stuffed up a cow's butt. We've got that all connected and happy. Okay. And, the cow's really thrilled.
Hold.
This is no animal anything. It's just for the Netherlands, right? We love our cows.
You said something important. You intersected it to the LoRaWAN. You intersected it to something that can affect the safety of consumers and society.
Everybody.
And this might be the intersection of where security and safety meet each other and why the path to IoT security really, really matters. Because then it becomes a safety question. And we just heard that the other operators were allowed to go live without doing what they did. Why were they allowed to do that, Katie?
Sorry, say that again?
Why were they allowed to do that, Katie?
Do what?
How could the other telecom providers be allowed to go live with untested LoRaWAN systems that potentially could end up impacting safety for consumers?
It's not just LoRaWAN
and infrastructure.
It's not just LoRaWAN, because LoRaWAN is not a standard. There's also narrowband IoT. There's a whole bunch of other ways they could do the same thing.
Anything that they get allowed to go online with?
Well, number one, I'm sure somebody tested it. It's just whether or not those people had enough time, resources, or skills to adequately test is the issue. All of these, manufacturers of technology and even designers of architectures and protocols, they do some level of testing. It's just not clear what standard of testing they're actually following and whether or not, they had people who were sufficiently skilled to find them and given enough time.
So, since we're talking the path to IoT security, could legislation help fix this?
Can I answer that? I don't believe the path to, salvation in any respect is more regulation. The best stuff we have wasn't built on the foundation or premise of regulation. Why on earth would we think we could fix it that way? So I don't know if that was a fair question to you, but what I'm suggesting is that this was an excuse why, they weren't testing, not necessarily like an actual truth that they didn't test. It was just that we were very strict, we were very clear, we wanted to break the crap out of it and then fix what we found. And furthermore, the LoRa protocol actually has some smart things built into the premise of the protocol. There are still things that we want to improve, and we try to implement it to the best of our our ability, but there are improvements that we made back to the LoRa Alliance to improve how LoRa works. And it's not just about LoRa, it's about that crossing into the physical space. I was in Finland with, Mikko Hipponen, and he was pointing out that IoT, like the physical concerns for the Finnish, the biggest concern is, what if they hack the sauna? Because all these Finnish people, they all have saunas attached to their houses, and if you break into your sauna and then just set the temperature setting all the way high, your sauna could potentially catch on fire. So, huge concern. If you're Finnish.
You could make Finns extinct in a night.
So
they have a sauna each.
Back to the can legislation or regulation fix this? I want to kind of bring it back. There was a theme yesterday and today of using the word responsible with disclosure. I know that's the common term. I actually detest that term. I use the term coordinated vulnerability disclosure because it doesn't carry a moral, kind of a moral baton that's usually used to hit researchers. But if we take a look at that word responsible in disclosure, so much pressure is put upon the researcher to be the responsible one, where we have vendors who are releasing technology that has had very minimal, if any, testing. So back to your question about regulation and legislation. I work with some agencies in the United States, like the Food and Drug Administration, and I helped inform some of their post-market medical device cybersecurity, guidelines for medical device manufacturers. And what do you think I influenced them to put in there? Follow some standard for receiving vulnerability reports from security researchers, because that is a regulatory use. That is a use of an agency that governs and will approve devices like medical devices, and they do have the ability to influence their constituents like medical device manufacturers, hospitals, etc. They have the influence to get them to do better and be more responsible when it comes to security. So it's part of the solution. It's not going to solve the problem, but I do believe that there is a place for this in putting the appropriate recommendations and controls on vendors to step up their security and definitely step up their ability to hear from people like you who find vulnerabilities.
So I think there's going to be two big sticks wielded as well that will encourage device vendors to take this seriously. There's the GDPR regulation coming into force in a couple of years in European Union, which will mean that any vendor or database breach that leaks personally identifiable information will mean that somebody's liable for a fine of up to 4% of their global turnover. Not their profits, their turnover, because profits can be hidden, right? So that is a huge stick that the EU will wield. And the other is some interesting new business models springing up around vulnerability disclosures and hedge funds, reputational damage, and hedge funds making money out of vulnerabilities.
Don't go into that. That's for the next panel. Please.
Okay. Okay. Maybe you guys have some questions or comments. Should we open up?
Yeah, there's a question.
Oh.
You want to give him the mic? No,
Stand. Okay.
because we can't hear you.
Yeah, no, that's true.
It's just around the comment that with the whole regulation and all these type of things, and I've heard this conversation so many times of like, yeah, we need to do something to secure it and it starts with us. But the reality is there's normally like two sides. Like I think most people in the room here want secure stuff, But the reality is the business is also putting out stuff because there's pressure for them to put out stuff into the market. If you don't do it, this guy's going to do it, and my business might not exist tomorrow. And then there's the flip side of regulation. And I want to find out from you guys, what do you think is going to be the event that triggers it? Because now we go from the 2-dimensional to the 3-dimensional, where there's physical harm. So my fear is that there needs to be a compelling event that happens where somebody crashes a car with lots of people in it, or a catastrophic event, before we really, really take this seriously. And do you guys think that's the same?
Well, unfortunately, I think you may be right with that. That being said, I'm not going to wait for that catastrophic event to happen before I take the responsibility that I think I have as a network provider to do it correctly. But I do think, by the way, I was maybe a bit overly harsh on the regulators, wherever they may be, rest their soul. Because what I really do think is there is a role for them to play, if only to promote and encourage standardization in the right way, to require certain things. So there is a role for them to play, which would be a very positive impact. It would help device manufacturers know their specs and build accordingly, rather than having Zigbee, Z-Wave, blah, 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 name it, every single protocol and their mother available. It would help us get better. So there is a role to play. And yeah, I think we can get it right before we have this huge catastrophic incident.
What would you define as a catastrophic incident? Would you define half of the United States power grid going out? Because that occurred already as a result of a worm. Right. So, yeah, but what I'm saying is catastrophic events alone are not enough to drive these changes, quite frankly. We have known about these threats to critical infrastructure for as long as those devices have had computing in them. And like I said, it has already occurred. Half of the United States power grid went down in, 2003? And that was a result of a worm hitting one of the devices that wasn't supposed to be attached to the internet, and turning on and interfering with the sensors for essentially that are supposed to stop a spread of a massive power outage. And the only thing that stopped it from hitting the entire United States was a physical break somewhere in the middle. That is literally what it was. So we've known about this, and these events have happened. Now, to your point, I think that what does drive these changes are exactly that competitive angle, because what caused Microsoft to actually write the trusted computing memo, trustworthy computing memo? What caused it was their biggest customers threatened to replace all of the Microsoft boxes with Linux, because the worms were just ripping through their infrastructure, and if they couldn't use those computers, they were just going to absorb the cost of changing over to Linux and training all their users on Linux. So the bottom line of economics, I believe, is what drives these changes.
Just getting to the trusted computing point, I was very surprised not to hear about Trust Zone for microcontrollers coming in from the ARM architecture perspective, which will add some kind of isolated environment for every single microcontroller. And I think it's down to silicon manufacturers and architecture creators to create these patterns for microcontrollers and devices, and make it as easy as possible for device makers to not get it so spectacularly wrong every time. So that's a technology, I think, that will help the billions of devices that will use some kind of microcontroller benefit from some level of security, even if it's connecting to a mobile operator network or a LoRa network, or just going straight through the user's home equipment. You've got to add some level of trust to pretty much every single device if we're going to counter a lot of these threats.
So a technology fix at scale at that scale seems okay, but we will still have all these developers pushing out basic security flaws over and over in new IoT devices that get produced and pushed to the market every single day. It doesn't really address that. So how do we get developers to write better code universally and do a secure hardware design by default?
Well, I think what some of the things that ARM is doing, like creating the secure microvisor and creating the Trust Zone M pattern, those things are going to help to create secure by default devices. This is where the room full of experts needs to come together and help the device manufacturers build these things.
Yeah, but they may be secure by design in the first place, but what security researcher would be content to say, oh, no, that was designed securely, I'm not going to test that to see if they missed anything, or if there are advancements in technology such that previously unexploitable vulnerabilities or thought to be unexploitable, now there's a brand new exploitation method because of one of you fine people out there. So I think it's a point in time to be designed as securely as possible, but at some point you have to ship, and at some point you have to be ready to address vulnerabilities as they come. We were talking yesterday, the phrase kept coming up, you can't patch hardware over the air. I think with IoT, one of the biggest problems in maintaining security is the fact that when you have a hardware device that's very difficult to update or replace, even some of the security recommendations that make sense from a anti-hardware reverse engineering standpoint, disable the JTAGs. Well, then, okay, then how is the maintenance crew going to get back in there and deal with it if it needs to be dealt with? So, on the one hand, you're doing device security at the lowest levels and trying to design them as securely as possible in the beginning. But if you have no capacity to understand what's vulnerable after the fact, that's why that post-market medical device manufacturing guideline says you have to have a way to process incoming new information about vulnerabilities in your device. Still doesn't solve the deployment problem.
And to add to this, the other issue that I am actually not sure how we're going to address at the moment is actually, how do you even do detection? So if you say, look, I've got some sort of preventative measures, so I'm going to try to do all this good security features, I'm going to deploy secure protocols, I'm going to try to make sure that my developers have these secure environments that I can work with, great. But now, still shit is going to happen, and you're still going to want to be able to detect it. How do we detect it with the heterogeneity that's there without actually understanding behavior in this multi-protocol environment? Yeah, how do we actually understand what anomalous behavior is going to look like in this really diverse landscape of devices, nodes, networks, and protocols? And there's a really interesting project that Michel van Eten from the Technical University of Delft is doing, where he's actually wants to deploy these IoT honeypots. And I think that's a really good start. I think it's a really good place to try to figure out, okay, let's take a look at all the traffic. Let's see if we can analyze and get to some patterns. We're not going to get there to the point where we say this is the normal traffic and this is the bad traffic. We're not going to be able to do that right away. But, I don't have a good answer to figure out, okay, we built it, maybe they will come, and now what? How do we actually do the rest of the security lifecycle before we even get to fixing the vulnerabilities when they get reported? It sounds like it's all post facto. I'll figure it out when it happens kind of thing, rather than kind of preemptively figuring out what your lifecycle is going to look like.
Okay, so I'm going to posit a statement to you. Imagine if we fixed the CVE system. So we had a new entity handling that, so we consistently got CVEs for the known vulnerabilities instead of having 6,000 vulnerabilities with unassigned CVEs for 2015. So imagine a new system where we have CVEs for everything. Then imagine we have a requirement to know which libraries you build your software and your tools from. And you can stuff that library into a new tool that just got released, which will tell you if you're using any known vulnerable libraries. This would maybe help developers at scale, even in small manufacturers, to quickly remediate a large amount of vulnerabilities. What do you think?
Dude, I love you. So I could try that. But we started talking about this last night because one of the fundamental failures that we have in the industry as a whole is I have no clue what's running on the stuff I have and I've put in my network and I've bought. What's running on it? Like when we had Heartbleed, and I'm going to give it back to Katie in a minute. When we had Heartbleed, we had we had no idea where the heck it was across our network. Like, not from a component device perspective. When we had Shell Shock, same story, different day. You show me everywhere it's running. It's an open source library, but proprietary vendors, they don't know themselves very often what the heck happened. So first we were just scanning and trying to look for places where we could find open. I'm looking at the guy over there. So we were looking to find it on our network and see, is it running? Is it there? A very reactive mechanism. But we don't have any way to fingerprint open source libraries across, all of our vendor landscape, and they themselves don't know.
Do you want to go?
I'll say something.
Software bill of materials.
I think if you're going to have a software bill of materials, you're going to have a very good way of identifying the devices. So pretty much every kind of device is going to need some kind of identity and some kind of birth certificate if you're going to find all of those devices with all those vulnerabilities. More than a MAC address, some kind of securely programmed identity.
Okay, so I think the original statement was, what if we could fix CVE and have identifiers for everything? How many of you who do, any kind of penetration testing have run a vulnerability scanner and have it light up with a whole bunch of already known vulnerabilities, right? Many, many, many. Yes. So having more numbers assigned to the vulnerabilities, not going to solve the problem. Having a bill of materials of what's in a device, that's great. But again, at some point, you have to ship. You have to ship the actual device. How many of you have actually shipped a product for sale? Okay. And so any of you who have actually been developers or hardware manufacturers who had to actually ship a thing to sell, you have to stop at a certain point. And you have to end your testing, and you have to ship with what you have. And so essentially, it's going to work to a certain point. It will certainly take out the egregious, like five versions ago, old vulnerable thing that's getting put into a device. But you can't keep updating when you're making a device in progress and expect to actually compete in the market. Because somebody will do the lazy thing, cut those corners, have the shiny stuff, and win before you even have a chance to set up a vuln disclosure program because nobody is your customer. So there's a certain point where that can't actually work. And so what will happen is there will be an exception regime. And the exception regime will have all of the corruptible stuff happening in it. So I don't think it's going to solve the problem just to have exhaustive list of CVEs plus a bill of materials, because at some point commercial realities come in.
1 second. As a CISO, you know the fact that you have to fix the most amount of risks for the least amount of money in the fastest amount of time, right? Isn't it our responsibility as security people to ensure that the largest amount of companies can provide the best possible products in the fastest amount of time?
Yes, I mean I think that goes without saying. But the clue is, the bottom line is, I have no idea what we're getting when we buy something. I get a product with undocumented features and stuff in it, and at a certain point in time, the question becomes, if it's on a regular business operation, it shouldn't already, in that point of fact, be acceptable. But where it becomes worrying is, if I call a vendor and I say, are you vulnerable for this? The answer that I expect is not, I don't know. And that's what we're getting. We have vendors, and these are not the little boys. These are enormously ginormous vendors. I guess enormous and ginormous is the same word, but orders of magnitude. Big vendors, big ones. And they have no idea what they're selling to their customers. Open source components that they've put into their products, they don't know what they are. And I'm not asking for a bill of sale, actually. And, the CV thing, that's a nice feature, but I'm not asking for that. I'm just asking for the people that do ship, at whatever point, actually know what they're shipping. At whatever point, the time that they ship, maybe 6 months after, or when they introduce a new release, I don't care, pick a date. Just let me know. The last time I checked, I did actually have OpenSSL running, and this was the version. That's all I need.
I'll ask you a question. Do you think that something like a common criteria evaluation of hardware is something you'd like to see?
I don't know. I mean, again, necessary road to evil, labs, testing, validity. There's people who have EAL7 levels who I think, really? You've got an EAL7? So how good is an EAL7 level then? So, no.
I heard you guys say earlier that legislation is probably not going to solve it. But how about actually making vendors liable for gross negligence in patching stuff? I mean, if they don't know and things break and somebody's damaged, then if you have a legislation that they're actually responsible for the fact that they don't know their own stuff.
So software liability is your question, right? That is, so let's look at that for a second. One, we have rating systems like, for a toaster is not supposed to burst into flame and set your house on fire, right? No matter how long you've owned that toaster, it's not, it's essentially not supposed to be end of lifed, out of support for not bursting into flame in your house, right? But if you try and apply that to software liability, one, you end up putting a very, very big burden on small and innovative technology companies with compliance. I used to work for Microsoft 7 long years in the joint. I should have like little teardrop tattoos. But anyway, that taught me a lot, actually. Taught me a lot about commercial realities. And even a a mega,
Mega-enormous.
yeah. Even a Voltron-like company like Microsoft, has limitations on how much resource it can put into any, basically commercial realities of security. Imagine a very tiny hardware device company that is maybe a 6-person company. This was something also very interesting to me hearing from the FDA. On average, a lot of their medical device companies are 6 to 8 people. So can you imagine having additional software liability on somebody who's basically just trying to do a startup? You end up with even mega companies are the only ones who can compete in that market. So it's an interesting idea, but I think that there's some issues with it in terms of stifling innovation.
We actually do have that in the Netherlands. It's called zorgplicht, or duty of care. It's imposed on all the vital infrastructure in the Netherlands because you want them not to screw up or let stuff, burn and die. And the clue is, and I think this is a really big clue, because in the EU we have something around information security called the NIS directive, right? So everyone has got to do their bit. Everybody is supposed to be responsible for this duty of care, with the exception of hardware and software vendors. So clearly, something is broken. And although I have a deep respect and empathy for startups and small innovative companies, I do think that the large companies are making a play as an argument by using this. Oh no, it's too much of a weighty thing for us to comply with. You're preventing us from being innovative, not at the lobby level that they're using in the EU to come out of all of the other restrictions that are applying for every other sector except for them.
Katie, I think that there's a thing called due diligence and due care, and as Jay has also been saying, it's a small company. There is only the amount of due diligence and due care that a small company can do. So that's different from Microsoft. And right now,
Right. You go, and then I have a very specific case.
Let's do a quick
this
poll.
was talked about.
How many here think it should be legal for companies to push out products and services and software that can kill people? How many? Put your hand up if you think it should be legal to do it.
That's a really
weapon systems.
There's technologies out there today that do kill people, so that already exists.
They're totally guns. Anyway.
Did not say whether it's intentional or
wait.
unintentional, which is an important difference.
All right, hold on. Let's get back to the
Yeah, so the point was mentioned earlier today that as a vendor you have to try and look at all possible vulnerabilities, the ones that you don't even know are there. How do you find them? Right. Yes, you can only go to a certain amount of effort before you've got to ship the product out the door. So what is the right amount of effort?
Okay, so very specific case. How many of you heard of in the United States, we've got the Federal Trade Commission, the FTC, right? It's another regulatory body. It will sue companies for false advertising, things like that. How many of you heard of them suing ASICs? No, none of you heard it. Okay, so except the American over there. So they sued ASICs because they were basically falsely advertising their security. And part of that suit that they won was the fact that a security researcher tried to tell them about a vulnerability and they ignored it. So this is already taking place through the existing mechanisms that at least my government has, and I'm certain other governments have as well. So that is one way in which that negligence was recognized, and it was part of the case, and that was ASICs.
All right. Any further questions?
No, just a quick comment to the question if it should be legal for companies to sell products that are able to kill. I think it really depends on the part of the ability, because if I would have expected more hands to be raised, because otherwise you should really think if you drive a car, or if you board a plane, or if you go on a train ride, right? Because these are all things with the ability to kill somebody, right? So software is the same thing. You have to think what's the benefit of putting it out and what's the risk that it imposes.
But software is the only one with no liability.
I'm not sure where we're going with this, to be really honest, because I'm not sure about the whole death and destruction and doom thing. But I want to make a look. As KPN spends about €1 billion a year on IT, roughly, give or take a couple of million. I don't know. It's not my money. The clue is it's a lot of money to spend on IT for very big vendors, but all you're expecting is some reasonable amount of care and attention. You're not expecting them to fix, like what you said, we don't expect every single vulnerability to be found. There's no reasonable expectation of that type of diligence. Otherwise I wouldn't need a red team. We wouldn't need the numbers that we have in security to make sure all of the things where we try to paste all of the products and services together, that all needs to work. So when we test, we're testing the ecosystem and not just one single device, and not in all cases, in any case, when we want to push out a service. So I don't expect vendors to go crazy. I do though have some expectation that there's not complete incompetence. Is that, there's perfection and there's complete incompetence. I want something kind of in the middle, depending on how much I'm paying for the vendor and what their relative importance is in the food chain of the service that we're delivering. I want them to be able to tell me when asked, is there a problem? There is a vulnerability that has been issued. Do we have a problem with your component? I want them to be able to say yes or no and say we have this component, we do not have this component in our overall software, hardware, service, etc. And that's it. I don't think that that's an unreasonable request to have.
You can finish off, yeah.
Sorry.
I think we should talk.
Okay, so I guess we're kind of wrapping it up. I think the perspectives here are really, it's really clear. There's a tension between the people who, have to come up with this technology and somehow fund it, meaning sell things. So vendor's going to vend. We've got the buyers and the deployers of this technology who, at varying levels, KPN very much cares about the security of it. Some other carriers, not so much. But we've got, essentially the consumers and deployers of this technology who are having to evaluate whether or not something they're putting into their systems is actually suitable and won't cause loss of life or loss of or damage to critical infrastructure. And then there's essentially the hacker community, right? I think one of the greatest things that Sergey Bradas said yesterday was, if we lack the tools to appropriately test something, we need to assume that it is insecure. So I guess my request of all of you is continue. If you've been looking at my Twitter for the past couple of days, I keep tweeting out the resources that you guys are putting out. Resources, links to the tools. I think that it's going to be fundamentally so important for us as a society to secure these systems in making sure that you, who have the will and the ability to create tools to test them, are doing so and encouraging other people and teaching other people. So thank you, hardwear.io.
Are you closed off?
No, I'm quite open, actually.
What I meant is, you're good? Yeah. You're good? Is there any time left? Are we finished?
3 minutes.
Any final question to the panelists? Yeah?
Yeah, sorry, I had to ask another question, but it's Katie's fault because it's something that you said that triggered me on that other one.
Trigger warning.
Yeah, so you mentioned that the economics thing. So, and this is maybe a utopia thought. So this is just something I want to throw out to you guys and find out what you guys think about it. Do you think it would ever happen that security becomes the business competitive reason why people buy the products instead of that? Because that changes the game. Then I'm going to put a product out because you're going to buy mine because it's more secure. Do you think that would help solve the problem? And do you ever see that happening?
I really hope so. I really, really hope that is the way that we're going to go, because that is what we see as the improvement of our networks and services. And I think that utopian view is something we really would like to see in a very short term rather than waiting forever for it to happen. And I think, actually, maybe it's a call, again, to action. I think everyone has a part in this, vendors as well as buyers, to make sure that they're not just buying crap, or at the time that they're buying it that they thought that it was secure, yay, but as it goes on they get complacent and don't keep on track of these things.
I think definitely secure devices by default has to be the norm. It has to be a hygiene factor. It should be that no device ships in an unsecured state. Security has to be built in and low cost, so much that it disappears into the bill of materials as well. And that's what's going to get us there, to that utopia.
We are in the Netherlands, so whatever you have been smoking, please share with everyone. No, I think that that I love that idea, but how many commercial failures have we seen that actually attempted to do that? Does anyone remember Plan 9? Yes, okay, old people, awesome, just like me. Right, but those are more recent commercial failures. But Plan 9 was something that was an entirely new security model, or it was essentially very, very, very secure. Pain in the ass to get anyone to develop anything for it. It was a commercial failure. Similarly, if you look at the consumers, whether they're an enterprise consumer, it depends on the enterprise. The average lifespan of a CISO in role is not one like Jaya has done, where she's been in her role for quite some time. The average lifespan of a CISO in role is 18 months. Now, what CISO is going to basically risk their business's bottom line by trying to switch over to a more secure technology and potentially disrupt their business? No, they're going to keep the status quo. Some of them even request of the vendors, I've literally heard this when I used to work at Microsoft, could you maybe not release patches every month? Could you maybe just roll to quarterly? Because it's just really expensive for me to deploy those. And so could you maybe not? So I would love for the utopia to exist and there to be enough buying power behind security as a differentiator, but frankly, it is not. Potentially, in the consumer space, that may become a factor, but the consumer space, just like they were awakened to privacy by the Snowden revelations, they have not completely been awakened to security and having that as a requirement, nor do they have the ability to properly evaluate. It's a market for lemons. They don't know if one product is really as secure as it says it is. So I would love it if it were true. We've seen commercial failures, in that space before, and I believe it will continue to be commercially not really a big differentiator.
Let me just ask you guys one question, and maybe specifically to the guy who asked the question. Do you pay for anything you use which actually adds to your security? No, it's not a loaded question, because this guy, no, I know, I get it. But this guy over here said, the black phone. And you know what? I have to be really honest. How many of you actually thought to buy it? Exactly. He's not. No. So the point is that a lot of people want better security but aren't necessarily willing to put their money where their mouth is and pay for it. So that means there is no economic incentive to actually do it. However, I do think, now here we go back to regulation, that when it comes to duty of care, you've forced the incentive. That's where regulation plays a sort of artificial stimulus. Because of duty of care, companies have to protect their data and have to show that they're doing everything that's possible to protect the user data or, PII information. So in that sense, they have to buy more secure products, because otherwise they will fail in their duty of care, zorgplicht in the Netherlands, and there you've created an artificial stimuli to make sure you buy those kinds of, if you have two choices, you're always going to take the more secure one. You're going to take the one that has a better control over their patch and update life cycle, and that's different. And by the way, I've been at KPN for 4 years, so I need a new job. Anyone, just...
All right. On the note that the user will never choose the most secure alternative if it costs extra, and it's our job to make them secure, let's finish, and I hope you got some value from the panelists. Thank you a lot. Thanks a lot. That was